Alright, greetings. We will continue where we left off last. Now, until this point, all we've really been doing is scripting. We've got a single class file that controls all our code. Now, to make any changes and to incorporate any other elements, um, may theoretically work in a single file, but it generally doesn't. We want to make things very modular, very object-oriented, and as such, what we're going to do is we're going to start stepping away from a single file and work on multiple files that provide modules of functionality. Now, to do this, we are actually going to open up a program called Flash Develop. Now, if you don't have it on your machine, probably download it. I sort of showed you the web page, web URL on that first lesson, but you can quickly Google it. Just type in Flash Develop. But your machines probably will have it. So, and if you're not sure exactly where it is, you can just open up the Start menu and type in Flash Develop, and it should bubble to the top. And the reason why we want to use something like this is because the Flash IDE was not initially designed as a coding environment. It was merely designed as, a tool for scripting, for scripters. For coders, it doesn't necessarily provide all the subset of features that we're, comfortable with and used to. There's a lot more things that a programming environment could provide us with. And so we're going to try stepping away from this and work in another environment. But it doesn't mean that anything, in fact, really changes to the way we code. The code we will type out will be essentially the same. And all code really is, if you look at it, is just a txt, some sort of text. And I can show you exactly what I mean. If you go to the location of your file. Now it has a .as on it, but I can open it with, let's see, I'm going to open up Notepad. This is just a basic text reader application, and if you open it up, and it looks exactly the same way as we have it inside of our script. Script files generally are just text. It's the compiler, when we hit Control-Enter, or compile our application, it generally, turns it into machine language and bytecode, and then it does fancy things. But in, the initial form, it's highly readable. And most languages work the same way. So open up Flash Develop, and all we're going to do is we're going to switch our coding environment for this main AS from the Flash IDE to Flash Develop. Now what this also means is we have to create a new project. So go to Project, New Project, and it's going to be a Flash IDE project because we really want to tie it in to our current project, which is based off the Flash IDE. And I'm just going to call it Game Engine. You can call it Game anything, Game Prototype. I'll just call it Game Engine. And I don't want it to create a directory because I want it to actually be pasted in that directory file. And make sure Flash IDE is selected and hit OK. Now if you don't have the Flash IDE, you don't own it, then you could always create an AS3 and an AS3 project straight up that doesn't rely on the IDE, and you could probably skip a couple of the settings that we'll probably do later on, and it'll work essentially the same. You won't have any control of where your objects are placed, not from a visual standpoint, but you definitely have it through code. And there are other applications like the Augmo editor that will allow you to design levels and get it all functional with just using the a regular AS3 project. But for the purposes of this demo, I'm going to show off the Flash IDE project, So it says the directory is not empty. It should tell you this. You usually want to copy the template files there. Now, ordinarily, this would be a bad thing. But in our case, because it's a Flash IDE project, the template files is nothing. It's just essentially the project file that'll be generated, telling the Flash develop that this is the project directory for it, but it doesn't actually generate any scripts. So this is totally fine. If it was an AS3 project, it would probably try generating a main script, and if you had other files there, might overwrite them. But in this case, it's fine. Just hit OK. This is sort of what the layout should kind of look like. If you have your projects tab opened, so there are tabs on the bottom. This is your project tab. You can double click on the main file, and there's your file. There are different settings, and also make sure this is in debug, not release. There are different settings that you could theoretically employ, like the way everything looks. There are, tools and syntax colorings, UI themes that you could, templates that you could select to change the way your coding environment looks, and you can find those all online. So if you like a dark background and light text, you can do that. I generally just keep with the default because it works the best for me. So make sure your game FLA is opened, and if it isn't, you could always just double click it here and it'll make sure it's opened. This SWF is the file that is generated when you compile, and this is what generally put onto the web and other things. But we just want to make sure that it's working, so that if I just hit Control Enter here, it should kind of just run inside of the Flash IDE, but it's not. What did pop up for me is that it needs a path to the Adobe Flash Professional, and it wants that, which is good. So it's telling me that it's not currently set. You can hit OK, and it's going to pop this up. It's going to be under AS3 completion, and what it wants is a path to the Flash IDE. And so we could do it one of two ways. Either we can find the path. The easiest one I found is generally just right-clicking. If you do have it in your bar down here, you can right-click on it. Right-click on this application. Go to Properties. And you see this target path? That's the target path we want. Just copy everything except for the quotation marks. Hit OK. Paste it in here. Close. And now when we hit Control Enter, it should publish it out over there. And it works exactly the same way as when we left it last. It just kind of generates those, I don't even know what those are. Generates those objects onto the screen. Right, tons and tons of squares. I think it's, yeah, circles, the circle class that we created. And this is all tied into the circle class over here in the FLA. One of the quickest things I could kind of show you as to the immediate benefits is there are, just explore this interface. There are things like, if you take a look at the outline panel, it tells you all the different variables you have and functions you have in a class just at a glance. Also tells you other, interesting information like what you extend, and you can, I don't think you can do anything with it, but who knows. But what you can do is there is a really cool shortcut. So anything that is sort of highlighted in this gray is a recognized class. Now the reason why the circle doesn't actually highlight is because we don't actually have a physical class for the object. What we do have is a theoretical class that is, generates that when we compile, Flash creates a circle class and it's generated. Now, Flash Develop can't read that, So generally, we try staying away from that stuff. It's also good programming practice not to have classes that are just referenced in the linkage, but to actually have a physical copy. But one of the really cool shortcuts is if, let's say, and if you just start typing anything in here, you can just say like this dot, It doesn't have to be this. Even if you hold like Alt space, sorry, it's not Alt space, Control space, it'll give you a reference to all the different variables that are currently available and objects. And so, if we were going to like our hit test object that we saw last time, it'll tell us little nodules of information as to what it does, similar to how Flash kind of did it. But this is, it's a little bit more advanced. If you hit F1, it actually gives you a lot more information on it. You can condense it, consolidate it, depending on how you need. And these three dots indicate whether or not there is more information on it. But let's say this isn't enough. You want tons more information. Like we're dealing with something like a graphics, right? Dot begin fill, maybe. So, well, it's pretty detailed. But let's say if you wanted to actually read it in a little bit more of a, I don't know, proper format or detailed format or some other format, you can actually jump to where the code is. This is fairly useful for when you're typing your own code and you're like, wait, how did I do that again? By just clicking in the middle of the actual function you want to jump to and hitting F4, you jump to the description of that function. It tells you everything that it does and everything that's related to it. And just take note, it's usually above. And if it's your own documentation, so these are stubbed out functions related to Flash because we can't actually jump to their source code. But for your own functions, you'll probably just jump to your own source code, which is super useful. And if you want to write, this kind of documentation, you kind of have to do it yourself, which isn't the worst, isn't the end of the world. It's pretty easy to do. I'll try to show you how to do that in a little bit. But essentially, we can see that it has all the text here, evaluates an object, and this is exactly what you'll find online, which means that instead of searching for this stuff, and being like, okay, well, Google it, this is still a very good practice, but something that's a little bit faster, a little bit easier, is just clicking on it, hitting F4, and all the same information is almost readily available. If we go to like hit test point, we scroll down. This is also, we're in movie clip, right? So the display object owns, like we see over here, display object owns the hit test point function. And if we go down here to inherited functions, snap, pull it down to the side a little bit. Inherited functions, we can see where is the hit test point. If we click on it, you should take note that we're now in the display object class, exactly as we are in here, and it's jumping to hit test point. So hit test point is over here. And exactly as you'd see it, I don't know if the code's actually the same. Oh, here it is. Evaluates a display object to see whether or not the overlaps or intersects. Right, almost exactly the same. Tells you the parameters, x and y, coordinates to the object. Shape flag, what it also does, and it looks exactly the same text. Turns true or false accordingly. Fortunately, this example doesn't seem to be carried on throughout, but it's not the end of the world. Alright, so that was F4 to go inside, Shift F4 to jump back out. Also be very handy. And there are tons and tons of shortcuts, and I'll probably be calling them out as we come across them. So the first kind of thing we want to do is we want to clean up some of our code. So this adds a lot in regards in the ways of functionality, but it doesn't actually add anything in regards to the modular aspects of how coding is supposed to work. And coding is supposed to be very, very modular, very, very dynamic. And as such, we have to start making it modular and dynamic. And the first thing we're going to try doing is making a key manager class. And this is super important because if we want to access key presses anywhere, we don't want to have to do this setup code, right? We don't want to have to add these event listeners, which can be expensive, and we don't want to have to, trap individual keys. Even though it seems to be working fairly well, there's got to be a way to modularize it. And so as we start, working out, we're going to start adding, elements of functionality. Now, to do this, we also have to have some sort of structure. Now, we probably want to start doing is we want to start creating folders that group similar like objects. So utils will be our folder for anything that is a utility that operates on its own, that doesn't rely on any other snippets of functionality. So the first thing we're going to do is we're going to create a new class. So that was right-click on utils, add, new class, and we're going to give it a name. We're going to say it's going to be called key. Very simple class. Now we could extend an object, extend the classes, but we don't have anything to really extend. We want it to function on its own. And also that, nothing else is really going to extend that, so we can mark it as final. We hit OK, and you'll notice that's our first class. Hits key, looks like key. And we got to start thinking about how we want it to work. Now, generally, what we're doing here is we're saying, is right key pressed? We're actually setting a Boolean to see whether or not the right key was pressed. And we're evaluating whether or not, that keyboard is equal to that key code. What we essentially want to do to modularize it is we want to set infinite amounts of these booleans. Now, infinite regards to like any key that is pressed should set a boolean to true, and anytime it's released, it should set it to false. Now, this works out really, really well until you realize that the only way you may have to do it is like typing out hundreds of these booleans, and nobody wants to do that. That's not the purpose of OOP. The purpose of object-oriented programming is to make things simple and modular. So that's going to be our first problem. The second problem is we also need to add an event listener to the stage for the key ups and key downs. So how are we going to solve that? How are we going to handle that? How are we going to get a reference to whether or not the keys had been pressed? So this is probably your chance to give it a try, see if you can get this all working. At least getting these add event listeners working inside of the key class. If you can, good on you. If you need a little bit of a hint, the one thing that you can do is you can actually pass in variables to your constructor, similar to how we have these parameters, these events being passed into this onUpdate function. Go back to the first tutorial. I showed you how to do, right at the end of it, I showed you how to do a sum function where it takes in multiple parameters. You can do the same thing inside of this key class. And if you couldn't get it, if you did get it, good job. If you couldn't get it, I'll show you how to do it. It's just inside of our constructor function, we can take in any parameter we want. And so the first parameter I'm going to take in is a reference to our stage. The reason why I also like starting with the key class is because it's self-contained. It provides worlds of functionality, but it's completely unrelated to everything else. So it's a good way to start getting into the flow of things. Now, that's our first step. So we could probably cut these 2 lines of code and paste it in my inside of the key class. Perfect. Also, you'll notice that it did the import for you automatically for the stage if you typed it out the way I did. Now, if you didn't, if it didn't pop up, you know, it didn't auto-import, you can also hit Control-Alt-Space, and it should give you the right reference to the stage, and you can just hit Enter on that, and that should auto-import it for you. Or you can type it out like you're used to. I generally try to stay away from it. Control-Alt-Space is actually your friend, so I'm going to show you something. Control-Alt-Space. At the end of this function, no, that didn't do it. Control-Shift-1, there we go. It pops up another information dialog, and this is sort of its autocomplete. Okay, you know, it sees that you're, you know, you have an add event listener function, and the second parameter is a function that it should be taking in. Now it's asking you whether or not it should generate that event handler, i.e. create that function. And you could just hit enter on that, and there we go. It says private function on key down. I didn't have to type any of that out. It just kind of did it itself, which is great, because programming should be kind of fast and quick, right? Generate event handler. Good, so we got one for up and one for down. So up is our release. I'd actually rather reverse these two. What else we got? Perfect. So these are actually taking keyboard events. Inside of my key class, I just took it in as a regular event, which is not really good for me because we actually need those key codes. So key board event, there it is. Just pops up. And it auto-imported that for us as well. Now I'm not actually using the event, so either you can go up there and just kill it, because I increase your compile time, or you can go to refactor, I believe it's optimize, or was that organize? Organize imports, and that kills the unwanted event. So now this is all kind of working. We can go to our outline and we can see we've got 2 functions, private functions at that. We've got our constructor that takes in a stage. These 2 take in keyboard events. They don't return anything. That's fine. Now the question is, how do we trap all those keys? It also means when we initialize this key function. Oh, one last thing. It also means when we initialize this key class, we actually have to say right at the beginning, new key, because we need to pass in a reference to our stage. So we can start trapping those events. We never really have to store that in a variable because there's no sense. And there's going to be a reason. I'll show you why we don't in a little bit. But the question that we really have to be asking is, how do we dynamically store these booleans? Now, if you could figure it out, good on you. Now, if you couldn't, I'll give you a little bit of a hint. The hint is, you take a look at arrays. Arrays do something fancy. And if you have experience with arrays, this will make a little bit of a sense. Little bit more sense. If you don't, you can always try Googling them. It's probably a good practice if you have no idea what I'm talking about. Just AS3 array. Open up the API reference and take a look a little bit at how they kind of work. Now this is application of knowledge. This isn't it isn't readily apparent how it's going to work. There is a little bit. We have to utilize the class in a way that you probably wouldn't initially think of. But take a look here. See if I can find some reference to what I want to show you. Alright, so if you were able to find it, you know, read up and get array access to kind of work, then good on you. If you weren't, then take a look at this array access. Array access tells us it's an operator. This actually teleported us to the operators page, and it tells us how we can kind of access arrays and, you know, multi-dimensional arrays and whole varieties of different things. All these are very fancy concepts, and we might get into them a little bit more. But at this point, if you take a look, this is how you access an array. You can access an array at a certain location and set those values. Now, this value we put in here is usually some sort of object or a number. That's how we generally access arrays, is through a number, as you can see. But now this number doesn't have to be static. I don't have to say at location 0, at location 1. It could be, you know, a variable number. And that's exactly what we kind of utilize to our advantage, you see. Sort of, you know, my array at I could be any property name. It could be a whole variety of things you can set an array. Now, if you're able to, this sounds like it's interesting and you want to still give it a try, go for it. If you have no idea what I'm talking about, just listen a little bit longer. I will show you what I mean. So over here, what we want to do is we want to create a private var keys list. And I'm going to call it keys down list. There we go. It's going to be of type array. And it's going to be equal to just a blank array. That's how we declare a blank array. There's another way. You can also say new array. Both ways work. I like this way a little bit better because it's a little bit tidier. And what we are going to do is when our key is down, we can say e.key code at this location. How do I know this is going to work? If you hit F4 on that, it says the key code value of the key pressed or released. Now this is a key code value. It returns a uint, a type that is a number. That's like accessing your array at that location. Now arrays are kind of kind to you, are very kind to you in regards to the fact that they do not have specified lengths, and if I just jump to that location, it just creates it for me if it doesn't exist. And this is super useful. This is also a reason why we're using an array and not a vector. I will show you what vectors are a little bit later. And what we want to do is when our key is down, we want to say, oh, well, our key is down. Boom, set it to true. And when our key is up, we want to set, oh, are we down? To false. Fortunately, this IDE doesn't correct typos. Or it'd be perfect. Just needs to read my mind. The last kind of thing we want to do is we also need to access this from a global location. Now, we could say public function. Oh, try to create a function in which we can access this key information globally. So we could say, I'm going to start just sort of a precursor. We could say public function is key pressed. And it really doesn't matter what you call it. We can utilize it in different ways. But I'm thinking about modularity and also, you know, the future of how we probably are going to evolve this little utility class, being a little bit more advanced. So with that in mind, bearing that in mind, I want to, yeah, I think this is going to be a good name. So we're going to say is key pressed. We want to return a Boolean, whether or not it was. And we also want to take in the key to test. So key code, what key should I be looking for? Should be a uint, exactly like this key code is. And then all we do is we return key down list at that specified parameter key code that they sent us. That's it. If it's true, it's true. If it's false, it's false. And if it's undefined, i.e. we haven't pressed any keys yet, it'll also trigger to false. So all that works fine and dandy. But here's another issue. Now I'm not actually storing a reference to our key. If I say var key is of type key is equal to new key stage, and I say key dot is key pressed, that works all fine and dandy inside of the constructor. But here's the problem. I don't want to do this everywhere. It's not modular. If I just want it to work, how can I access it from anywhere? And this brings into focus a new concept called static. This isn't necessarily an operator. Let's see if I can find it. I believe it's going to be a keyword. Statements and keywords. So here we go. It should be a keyword. Static gives us information as to how it works. And you can actually read this. I'd recommend reading this, understanding what a static does. I will probably give you a little bit more information about it and run you through some examples of what it actually is used for and some of the power that there is behind it, but I'm not going to run through that explanation. You should definitely look at it. So you can pause it, read it now. I'm going to say static private. I'm going to make this a static variable because it needs to be if we're going to be accessing in a static function. And we're turning the function to be static. Static functions can only access static variables or static information. They can still take in parameters like we normally would. But anything else that's inside of this class has to be static as well. So even if I stored a reference to the stage, I'd have to make sure that was static. Now, so that's all well and done. So what difference does this make? This means I don't have to make this var declaration anymore. Take that back out. That was merely an illustrative point. And what I can do is I can say key dot is key pressed straight off the class because it exists as a static function. Now this is super powerful. It means I can access this anywhere. Is key pressed, we supply a key code. Now what this also means is I can get it to replace this on key down and on key up. Now right now I actually took out the guts of my stage add event listeners for my key presses anyway, so these functions aren't firing. If I were to hit Control Enter right now, my character isn't going to move. And I'm slamming on my keys, it's not doing anything. You could try it the same. Now what we want to do is we want it to work with our new key class. So we're going to say key dot is key pressed. Now which key we want to test. Let's say for the down I'm going to, this is right, so what is it, D? There we go. We're going to test our D key, and if the D is pressed, then I want it to move in the X direction. Oh, cancel. Same for whether or not the S key is pressed. We want to move in the down direction. Now if I save this and run it, it should just work. Wow, I actually thought I was moving the red cube, but apparently not. But anyway, it works. The little black one does, move, and that's super important. I also want to comment out that. I don't want it to keep on spawning those circles anymore. That was merely an illustrative point. The other thing to note is, no, I think that's it. 30 frames per second, that's what we're running at. That's a good frame rate to run at. We won't run into any other problems. And that's a very good example of a utility class. It's generated, you initialize it here, and it just works. Now, usually a utility class doesn't generally have to be initialized in this way, but because of the way we're adding event listeners, it's probably a good idea. You can do it in different ways. But for another time. So let's start cleaning this stuff up. We don't need the is right pressed and is the down pressed. But also means inside of our main class, we don't need any of these functions and event listeners. They just kind of work now, which is great. Our class has at 100 lines of code as opposed to the, what was it? 125. That's actually pretty good. I like optimizing code just as much as the next person. And inside of our key class, we can also see that it was a couple lines of code. It wasn't terribly much, but you know what? It's probably much smaller than it originally would have been. Had we had to trap all those other variables and keys. So maybe a little bit of additional cost, but you know what? It's super simple, super small, super efficient. So that's good. I'm happy with it. The next thing we kind of got to do is, let's see if I get this. So this was the simple introduction to object-oriented. This is your goal, making things modular and, you know, just work everywhere, at least for a utility class. But for everything else, it's modular. And so what that also means is when we're building out our engine, and this is going to be our next folder, it's going to be called engine, all our objects that are related to engine construction and engine manipulation should be put inside this engine folder. Now you may be asking, well, what's the first thing we kind of got to do? Like, what should be the root functionality of our engine? And the simplest place to start is an object that provides major functionality, provides the most important things for you, and the most important things, and we should probably make a list of this somewhere, so I'm just going to Control N. What's really, really important when you're creating an engine, it's access of objects. How am I going to access my objects on the stage? Collision. How am I going to collide with objects on the stage? It thinks it's an AS file. I'm actually just typing in a. I want it to be text, but it's text. Collision with other objects. So this is. It's supposed to be dynamic access of objects. And what else we got? Dynamic removal of objects. Now, since these objects are all dynamic, and this engine is all related to a game, what we probably want to do, and this is our first step, is to create that new object that's going to be malleable and going to be super functional. What that means is we're going to say new class, and our package is going to be engine, exactly as we see it. It's not going to be final because we're going to have a lot of things extending it. I should give it a relevant name, and so the name we're going to give it, or I'm going to give it, is game object. It's probably a pretty good name to give it. And the base class, because we wanted to do everything, you know, animate and potentially do everything that any other, you know, really advanced Flash the timeline stuff and all the really advanced Flash functionality, we're going to get it to extend a movie clip. And so this is our first extension, first game object, and we are going to hit OK. So this is our first, and you can see that it's already set it up a little bit different than the way the key was originally set up. First thing you'll notice is an extends movie clip. This is also the same thing we see in our main class, so it's not terribly different. Not yet. And it also does the import, but that's a nicety. It does all that stuff for us. The other thing we wanted to do is we actually want to call a super of our class. And what it calls is, it calls the constructor function of the movie clip class, which means if we hit a 4 on that, it calls this function. Flash does it for you anyway. It'll always call the super, but it's best to have control over when it's called, at least in the constructor function. Other functions you do have control as to whether or not they are being called, but in regards to the constructor, you don't. It has to be called. So super just calls the parent function, or the the base classes function, constructor function, in this case, and this particular concept. You can also context. You can also, I think, look it up in the. I don't know if it's an operator. It could be a keyword. I think it's a keyword. Let's scroll up to the top and see if we can find it. Up. There it is, super. So invoke superclass or parent version of a method of a constructor, and if you click on that, it'll give you more detailed information. Tells you how to use it in a very advanced context, but it doesn't actually give you an example, which is unfortunate. Alright, so you can take a look at the super function, if you wish. But what we want to do is we want to create a list. So part of our list is dynamic access of all objects. If we want to get dynamic access of them, we probably want to create a list for them. So you can create your list, and you probably already know what type of list it is. Give it a try, see if you can come up with what I'm thinking about before I come up with it. If you did, good job. If you didn't, here it is. Static public variable. It's going to be a list of game objects. Now this is really fancy because we're inside the class itself, which means this isn't necessarily the best way you generally want to do things, but for our purposes it work out very well. It's actually a list, which means it's a vector of game objects, which means we also take in a new vector as a constructor, because at some point it does have to be constructed. And what is a vector? I don't think I've shown it to you as of yet. I might have inside of the main class. Yes, I have. Vector of movie clips. Very good. And I might have explained it a little bit, but I'll go into a little bit more details. Benefits of a vector is that any functionality that we have in here, such as since we extend movie clip, all of the movie clip functions, we get access to and lets us see that, as opposed to if it had just been an array, new array. Even if we access it at a specific location, we have no idea what we're accessing. So you can try switching to an array and see what the difference is. This will give us compile time errors if we're trying to do something weird with it, which is good. Arrays give us runtime errors, which is bad, which means we have to kind of like go in and figure out which line is giving us the problem. Compile time errors tells us which line before the code actually compiles, which is very, very useful. So what do we actually want to do with this list? Now, this is inside the constructor function. This is an instance variable. Now, every game object that is ever created, we want it to actually be appended, pushed into this list. So what are we pushing? We're putting a reference to this, reference to ourselves. This is super important. Now, let me actually show you what this does. And this is all going to be technical. I'm not going to actually put any rendering to it because, you know what? I just want you to understand it as conceptually as it can be in its purest form. So if I type in 4 and hit Control B, it'll auto complete the for loop for us. And we can say we want 500 lines, 500 new game objects. Now what I want to do inside my game object is I want to push it, and then I want to trace. I want to trace everything in my list. Firstly, how many items I have in my list, and everything in my list. This is just a little bit of fun. Hit Control Enter. And it didn't do squat. See if I can find out why. Before it takes me there. What do I look like? Engine game object. That's all right over there. Well, it should have done something. Oh, no errors. Okay, let's take a look at the code in here. Let's make sure it's looking the same. Super weird. Oh, now it's working. Oh, it must have cached the old version of the script, which is weird. Flash doesn't ordinarily do that. But that can sometimes happen, so I just opened it up anyway, just so it saw that there was a new version, and then it loaded it up respectively, which is good. That's super important. That can sometimes happen. So we say list. We have a single item, our first object, and then as we go down our list, go all the way down, and we can see that it'll actually push in all 500 items. Hold on, maybe I can find. There it is, 499, right? And we could probably even find the 500 one too. I don't know where it is, but it's probably somewhere. There it is, 500. So, and it's tracing every single object we have in there, all 500 of them. That's a lot. And I probably could have showed you the same thing with 50. In fact, it would have been more advisable. But yeah, let's just say 50, same kind of thing. And it's still skipping my... Look, I'm going to save this thing. I'm going to close down my game FLA and open it up again. Just because I hope I can sort of force it to ignore the cached version. There we go. So, that worked for me. We got 50. Very good. We could probably even done the same thing with 15 or 10. But here's something else. So now if I take out the static, that's a reference to every... If you can imagine it like a static is basically a key ring, right? You can have as many keys as you want on that ring, but that key ring touches all of them, right? It has a reference through all of them. And that's how we're using the static list, is there's a single reference. It is sort of like a blueprint of a house, right? Our class is a blueprint. And a variable that is static is a variable on the blueprint. It is tied to the blueprint, not necessarily the house itself, right? So you could have multiple houses, but a static variable is a variable tied in a theoretical space to that house, to that blueprint. It is a key ring tying all the keys together. Probably not the best analogies. If you read the documentation, it probably gives a better understanding of what it is, but I like to think about it in theoretical terms. Well, maybe less theoretical terms. More practical terms. Right, so let's say if we take out the static, and we were to do the exact same thing. Control-Enter. I'm not getting out, but what is wrong with you, Mr. Class? There we go. Ugh, sometimes I wonder. You can see that we have just a single item in our list. Why? Think about it. Because the answer to that is fairly simple. Every single game object now has a list inside of it. How many items is in that list? Just a single item, because we're pushing that single item into that new list. To create a new game object, it creates a new list. But with a static list, it never creates a new list. Now this generally doesn't have much use in practicality when you're thinking about object-oriented, but in this particular case, it works out to our advantage. It makes things a lot simpler, and we could do things that would take out the static, because statics generally aren't good. But it makes it a lot more complex. So I want to see you just see the results immediately, and also because I want you to be able to drag things and drop them on the stage, and they should just theoretically work. We already know how to access objects. I mean, we did that for loop. Did we do that for loop? I don't think we did a for loop. With collision. Oh, no, we haven't. We could have. Oh well, my bad. But it doesn't matter. You can dynamically access objects that are on the stage. I already showed you how to kind of do that. You know, you can get a reference to a circle that is on the stage. I showed you how to cast that as well. And you can do that in a loop to access all forms of information, all different objects in the world. But with this method, what we're allowing it to happen is that whenever they are created, they'll be connected. Let me show you what that means. That means if I go into the main and I take out that for loop, which I already have, and I go into my FLA. Now, what say if I say go to the properties, and instead of inheriting from movie clip, I'm still going to inherit from movie clip. I'm just going to go to engine dot game object, which also inherits from movie clip. Now, if I click on this to make sure that it was found, it is very good. Now, if I drag these things, 4 of these out onto my stage, how many items will trace in my list? That's the question you have to ask yourself. And the answer is 5. Why? Because I generate 1 through code. Now, these 4 are the ones that I just dragged onto the stage. I have reference to all of them. This one is generated through code, and so that it's appended at the end. And the red one over here, well, that one isn't a game object. That one's just completely drawn through code, which means I have no access to it at all, at least in this stage. But this is one way that you can dynamically create objects. This is really, really useful for level building because we can do a lot of different things with it. And I'm going to show you in a little bit what we're going to do with it. We're actually going to start cleaning up our code a little bit as well. So we're going to start getting things working. I'm going to leave this on update loop. That's going to be useful for us. I'm going to kill this on move function. I'm also going to kill the generation of the square. That's happening dynamically through code. We could theoretically have made it a game object too, and we would have had access to it. Actually, let me show you that. Game object. If I make this a game object and do this the exact same thing, I control enter. We should have an access to 2 in our output. It's not actually tracing out because I didn't save my FLA, but let me try one more time. There we go, 2. One's the circle, and one's just a base game object. So the circle is this guy, and this base game object is this one over here because we don't have any other class attached to it. Obviously, you don't want to generate objects like this. I'll show you a better way. You can still use the graphics dot, begin fill and draw rect, but you want to do it inside of another file. So this is our engine. Engine is anything that is the core, the root functionality of our objects, but not the objects themselves. Not the functionality. This is sort of like building out the functionality. And if we go to add new folder, and we create one called game. This will be for any game-related functionality, essentially scripting. Scripting is a scripting functionality, right? So we're going to create a new folder called game, and our functionality for this game is going to be a player. We need a player, and we need it to extend our base class game object. Probably going to have nothing else extend that, so that should be fine. We also need to generate a constructor matching our base, so we have our super. Already pushed it out for us. And that's essentially it for right now. We also see that it's in the game package, similar to our game objects in our engine package, and our keys in our utils package. Package is just essentially the folder it's in. And you can have nested folders as well. We may see that, but I don't exactly expect it. But it's also a grouping of similar functionality. And this is just how we kind of create it and we think about it. I'm not actually going to generate my player through code, but you can. I'm going to start killing all the things that we're no longer using. So Take out square functionality. We want to get things working, so let's take out circle functionality, take out all this stuff that's generated through code, no more square. Great. So what do I want my add event listener? That's a very good question. I'll show it to you in a sec. What I am going to leave in is maybe hit test stuff. Just one reference to hit test because we still have to do that. And I'm also going to take out my key press stuff. We don't want it to happen here. We want to put code where it logically occurs. So inside of the player is where we expect the player to be doing his movement. We don't expect it to be done in a main class somewhere completely else. And as such, we want to put that functionality in main. So we want to create a update function. But hold on a sec. We could do one of two ways. We could create an add event listener because it is a movie clip, and on update function, run it in that. And, every time we'd have an Eve type event, and we could theoretically get it working. But add event listeners, from my understanding, are a little bit expensive. And the other thing is you don't necessarily have control of the order in which things occur. So with those two things in mind, what I want to do is I want to still have update functionality, but I want it to happen without being controlled by a listener. So how are we going to do that? Public function update. We're going to put this in our base object, game object class. Return type void. So every game object has an update function. Now what are we going to do with it? We're going to go through every single one of our objects. Control B to complete, autocomplete. We're going to say game object. Now because our list is static, we can access it straight off the class, and it also has a length. Go through the list at I for every single item we have and call the update function. Now, what that means is that it should be calling it for every object that's created. So we should say, we should throw in a trace to make sure it's working. Trace a reference to the object, and we'll let it know that it's updating. Now, generally, this isn't going to be used for too much because the player is probably going to be one of the only things that are going to be updating in our game. I haven't really decided whether or not I want to make a side scroller or a top down. But it doesn't really matter. The functionality is going to be the same. Sort of leaning toward side scroller, just because it's a little bit more complex. It's got gravity in there. Top down is a little simpler, but the reason why I kind of like top down is because I've been doing a lot of side scrolling recently, and I don't enjoy that nearly as much. I want to throw some variation in there. So, but anyway, suffice it to say, it should tell us which ones are updating. Now, we don't have anything generated in code, right? We killed all our circle references, so let's just throw a circle on there to see that it's working. Right, circle is updating. Great. Now let's create a new symbol. I'm going to call this one player. Circle is sort of like our dummy temp object. Player should also... Alright. Alright, and we're going to get this thing to extend engine. Oh, sorry, not engine. Let's actually find out where I put that thing. Go into the player, put the player in game, so it should be game.player class. Game.player. Check to see it's there. Definition for the class was found. That's great. Hit OK. Now inside of here, we just want to put our player object, and we can do interesting things with them later on. But let's just make him a circle. I like circles as much as the next person. And we're going to make him green. Green circles are great. I currently have set to... No, a circle's fine. Just got to line up my cursor. There we go. We'll make him 32 by 32, which is usually a good size. Powers of 2. And we're just going to throw him in the world. So, what were we testing? We were testing to make sure that it was working, so we hit Control-Enter. Right, we didn't save. We hit Control-Enter. We have them both calling the update. See, it's players updating and circles updating. That's perfect. And if I add any more, you know, they'd all say updating, and you can put as many of these guys as you want in there. I'll have like 3 circles updating to every, 3 players updating to every 1 circle. But it doesn't really matter. The important part is that it's calling. I think I am going to make a side scroller. It's going to be a little simpler, probably. We'll see. But I can show you the turnover, the way they contrast with one another. So let's see what else I got listed here. The other thing is that we are accessing this list directly. You can do things to protect your list, such as, you know, similar to how you have a numChildren and getChildAt function inside of MovieClip. Inside of MovieClip. Oh, well, it's actually inside a display object. You can do the same kind of thing, display object container, I think, for your list, so that, you know, no one has access to, like, physically mess around with it and destroy it. Cancel. So the first kind of thing is we've got dynamic access to your objects. Not only that, we've also got an update loop. They're calling the update loop even though they don't necessarily do anything. So if we go into the back to project, if we go into the game object and comment this out, then we should be all right. Good to go. We won't have that slowing down our game every frame. The other thing we really want to do is we want to give him, well, we're going to keep it top down. We want to give him a couple of variables. Now, we can do one of 2 things. But firstly, let's say we wanted to actually give him some sort of movement. So we could say override update. Now here it's calling a super.update. Now if you have 4 on this, it brings you to the code that's actually calling, which is your trace. Now, so if we were to run it, you'd see that the trace is, you know, in fact calling. Of course we have to save it first, but it's in fact calling. Right? All we have is the player. But if I were to comment out the super, then it doesn't run it. Now this is super important, right? Because sometimes you have code in a parent function that you don't actually call. And the other thing is you can actually control whether or not you want to call it above or below your own code. So let's say you want it to do something after you've already done whatever you need to do. Now this is all very useful, all very important. So that's 3 kind of states. It's before, after, and not at all. Now I actually take mine out generally because our update loop's empty. So why get it to do extra work? That's a good question. There's no reason. So we want it to actually move. And we want it to move in the x and the y, so we're going to give it a speed, var, private, var, speed. This is a good practice to get into, is equal to a number, which is equal to, let's say, 5. We want it to move by 5 pixels. I'm also going to create another private var velocity, which is the type point. Now a point is a special type of object that only has an x and a y. I like using it to kind of get a reference to our velocity. And the point has a bunch of other functions in there, such as, you know, you can get a length or you can normalize the length. A lot of other kind of fun things. It's got a static function for polar. That one's super useful for figuring out angles. And I may use it, but generally you probably won't see me. It works in a lot of different cases, but you need a specific instance to actually see it. So let's say we got velocity. So we want to say velocity dot x is equal to velocity dot y is equal to 0. That's good. We're done. Now we can also say if key. Now we have to import our class. So we typed in key. Control Alt Space. Select keys in your list. It is in mine. It's the first thing that comes up. Hit enter. Auto imports it up the top. And then I can say is key pressed, which key was pressed. And I can use keyboard. Not imported, so you can hit Alt Space, Control Alt Space on that. Dot. We'll do a ND, and then W and S. Now what are we going to do? We're going to say on the A. Now, this is a single line if statement. Generally you don't see me using these, but usually it's sometimes nicer to keep it a little bit more simple, smaller. Keeps my code a little bit more concise. You can even do it in a single line, but I don't like brackets cluttering everything up. So you know what? For this case, I may actually just pull out the brackets. But you can do it in a single line. Velocity dot x is equal to speed. That's 1. And you can do this. Watch this. You can say plus equals. Now we're also going in the A is going toward the left, which means we're going to subtract our speed. Now D is going in the positive direction, so I'm going to add my speed. This is in the Y direction, it's going up. And this is going down. So, now the reason why this works out so well is because they counterbalance one another. If I hold down both A and D, the sum value is 0. So you see you can hold down as many keys as you want. It doesn't really necessarily break the flow. The other thing we're going to do is we're actually going to move our character, which is we basically set our X and Y location. And I don't like doing it immediately because you can do other things as well with it. So I actually like to stub it out to velocity, and after we're done everything we want to do to our velocity, we can actually just set our X and Y to our velocity. And later on I'll show you, you can even do something fancier than that, but for right now, this works out really well. So we run it, and I think I blew it up. Oh, I'm missing brackets. If you caught it, good on you. I'm missing quite a few brackets, so let me just fix that all up. Control Enter. And you hold them down, and it's working. It's working. It's working, but not as we intended, because it's really not supposed to set it to. It's supposed to be a plus equals. It's been a long day. And we hold these keys down, and we can move. Now you'll also notice that you move faster on diagonals. You can easily fix that by normalizing your speed. So what is normalize? Look in the point class if you have no idea. I'm going to hit it. Normalize, it says. Oh, and see, it even has an example. Normalize 0.34, length is equal to 5. Now you can normalize it to 10, and it's 6 and 8, right? So it actually just stretches or shrinks. It sets it's the sum value of X and Y locations, the length, to be equal to a value you specify. In my case, I'm going to say velocity.normalize is going to be equal to speed. Now this also makes very little sense because I kinda I'm adding speed and subtracting speed in a whole bunch of places, so why do I want to normalize the speed at the end of that? You're right. I could actually just put these values to 1, and then with it normalizing to speed, it'll work out the same way. And that would work too. So if you want to do that, go ahead. But that makes no difference. So now, no matter which direction you head in, it's all the same. And if I hold both A and D, it kind of cancels each other out. Alright, I was just testing out my keyboard anyway, and it looks like different keyboards work different ways, but they usually have a cap of some sort, so after a certain number of keys have been held down, they stop taking inputs, and mine seems to be about like 3 or 4. When I hold down W and S at the same time, it kind of glitches out a little bit, but that's alright. So now we have it moving. Now that's great, we have it moving. The next important thing is to implement collision. So collision is, you want to go through a list of objects and test whether or not you collide. Now you already have the example of that first collision. This is how we did it. It's great. Now it's up to you to do another collision. I'm going to create another object and we're going to call it coin. We want this to be dynamic. Export for action script. I'm not going to export it right now. Let's make our coin yellow. And yeah, we'll leave it. I don't care. Line it up a little bit. Make it 32 by 32. Also, make a class for it. What's it going to extend? It's going to extend the exact same thing as our player. So it's going to be coin. It's in the game folder. It's going to extend the game object. It's a final class. And that's it. We're good to go. What's it going to do? Well, the coin doesn't really do anything. It's the player that kind of collects the coin. So, well, our task is, so let's hook it up. So you can do it one of two ways. I'm going to show you the other way to hook it up. You can just say game.coin. And look, we can see in a sec if it works. We just drag these out, run it, and we see that there's a whole bunch of coins on there. And the coins are all calling their update loop. Of course, even though because they aren't stubbed out, because the player stubs his out, doesn't call the what's it called? He's not calling his trace. But the coins don't, so they're calling the game object's trace, which is just that line of code. So to stub that out is fairly easy. It's probably just best to leave it stubbed out. And yes, it adds a little bit of cost to have everything calling their own update loop, but it's relatively small. It's gonna be the smallest thing in your game probably, unless you're generating a huge world, and even so, you could probably get away with quite a few of them. There are things you can do to optimize your code, and you can take this out so it doesn't get called on everything. But for the most part, unless you're really experiencing power problems, it's probably just simpler to leave it as it is. So what else we got? We got a bunch of coins there. Now we got to collect those coins. So how are we going to do it? Well, we need to do collision. So we need to do collision. So it's up to you to figure out. You already know how to do the main. You already know about looping. It's up to you. You already know how to, in the main, how to do the hit test. And you already know looping. It's up to you to figure out how to do collision between multiple objects dynamically. Do it inside of the player, and I'll see you on the other side. If you were able to get it done, good job. If not, I'll show you how it works. What we want to do is we want another for loop. We've got a list. Our list is the list. If you don't know what it is, it's this list up there. So list.length. We go through our list.length. And we want to see if something's colliding with something else. Say this.hitTest object list add I and list add I is not equal this. Now this is important. We're going to test through every single object, but we are also in this list, which means we could theoretically collide with ourselves. And Flash, if you do send in, a reference to yourself and ask whether or not you collide with yourself, it'll say true, return true. It does some math to figure out whether or not these two rectangles intersect. And if you send in your source, it's not going to be smart enough to say no, you don't intersect with yourself. Anyway, that's just a logical error. I mean, you obviously collide with yourself. You're in the same spot. So yeah, what happens if we collide? Let's collect it. So how do we collect it? We want it to remove it from the stage. So let's call a function called destroy. Now we don't actually have a function called destroy, so let's generate a public function. But right now I'm going to tell you game object is probably the best place to kind of do it. But for right now, just to see if it works. So destroy an object. Instead of destroying it, I'm just going to hide it. Now, essentially, it'll look exactly the same, but it still means that all their code is running in the background. So I run into these objects. Whoa! I'm invisible. And that's exactly as I told it to be. What I really wanted to do was list at i.visible is equal to false, because we were also game objects. Alright, I told you you could kind of collide with things that are self and stuff. So there, I'm collecting, theoretically collecting. If we trace out our list, we'll see our list is still the same length. And I could really do that to show you. It's not affecting us in the slightest. Now this is, can work in certain cases, but generally does not work. Because when you collect an object or you interact with an object, they're usually just gone. And it knows it's 6. What we really want to do is we want to destroy an object. So that's collection. It wasn't too bad. We collide with an object dynamically, and we interact with it. It's not the way I do it for a game, but it's in its purest form. It works. It's not modular. You have to think about how to make it modular. I will show you collection, though destruction of a game object. So destruction of a game object, every object's theoretically got to get destroyed. Now, if it's theoretically got to get destroyed, you can you got to do two things. Firstly, it's in a list. You can try figuring it out on your own. If you can, good job. Good on you. If you couldn't, then pay attention. We can say we've got two issues. One is that it's in our list, and the second one is that it's on the screen. Now, to remove it from our list, we've got to find its location. Now, we could do a for loop and say, similar to how, list at I is equal to this, because we know one of us in there is this. We could find our location that way. Now, that would work, except it's expensive. A cheaper way to do it is index of. It's one line. It returns an integer. And we can say list dot index of, trying to find an index location, and it's expecting a game object. What's the game object? This. Great. Now it'll find a reference to me, the object I'm inside of. Now remember, player extends game object. Even though it extends game object, it still has all the same functionality. Think goop. So now we found the index location. So if, and what happens if we don't find it? So you try calling destroy twice. So if index is, you can actually take a look at the reference, hit F4. Ooh, did it find it? Oh, there it is. Searches for an item and returns the index position of that item. No, it doesn't. Doesn't do too good of a job describing it. You can Google arrays to see index of. AS3 array. Index of is probably going to be a little bit better. AS3 array index of. There we go. Come on, don't fail me. Wait for that to open up. But here's the solution. It's greater than -1 because 0 is a valid location in an array. -1 is not. So if we take a look at index of, come on. Last index of. We can see that you can take a look at the example too, but int returns a 0-based index of the position in the array. If the search element argument is not found, returns a value of -1. So exactly as I said it. So if it's greater than -1, i.e. it was found, you can say list at index of. No, we don't want to do that. We can set it to null, but we actually just want to remove it from the array and let everything just kind of live on. So say list at index of, and delete just that element. This is actually also causes a logical error. Logical error that requires us to swap the length. So instead of counting up our array, we want to count down our array to update everything. And this just kind of works like this. Imagine if you have 1, 2, and 3. All those are indexes in your array. Now, if you pull 1 from your array, where does 2 go? 2 goes up to 1, the 1 index position. Everything just kind of gets smushed back together. Now, if I was counting 1, and I removed 1, and now I continue counting down, if 2 is moved to 1, then I'm now gone to 2, then I'm really on 3, which means you'll actually see a hiccup, where things don't update. One thing doesn't update for one frame. And in a large world, game world, it kind of looks weird. Smaller game world, not so much. You can do fancier things to mitigate that, but for a simple game engine, it's not necessary. So that's great. No longer updates, which means inside my player, even if I turn off the visible as false, when we collide with a coin, it won't trace. It'll only trace once, because that's only going to be in our array once. We'll just save again. I don't know why it keeps on failing. So when I hit the 6th item, it's still going. Oh, right, because I didn't call destroy. One more time. Ah. So hit the 6th item, and it's at 5. We hit the 5 item, and it's at 4, 3, 2, 1. Right. The only guy left here is player. Now, this works exactly the way we want, except it's not removing the render. Right. Our list is being concatenated. So how do we remove the render? See if you can figure it out. If you can, good job. If you can't, the thing you want to think about is remove child. Now, every object has a parent. Right? So, how does a parent work? Parent indicates the display object container that contains this display object. Use the parent property to specify the relative path. And you can also use it to go up multiple levels. But here's the trick. Now, if this you only have a parent if you're on the display list. So, if I have a parent, i.e. I am being displayed somewhere, let's say parent dot remove child. Now, who am I the child of? Oh, I'm the child of my parents. I could just say remove the child this. And we're done. So we hit Control-Enter, and we will see everything react the way we'd expect. Not only do you get spliced, you also get removed from the stage. And now you've collected that simple collection. Now I said that the player, this collection method isn't optimized, and I'll show you why. Because let's say I create a wall, new symbol, and we're going to call it wall. This one's going to be a blue rectangle. Make them blue. Make them really blue. Let's make it 32 by 32. Whoops. And we are also going to create a game object by the same name. So it's going to be wall. It's going to be geo. Now the player has to collect the coins but collide with the wall. So we run it again. Oh, bad idea. We put it on and we run it again. And if I run into that wall, you are a tough customer, my friend. He's not even a game object, right? Game.wall. It's been a long day, guys. It's been a long day. You can see it's part of our list now. So we got 7 items right here. Alright, so that's working. So now if we run into it, it's collecting him along with everything else. Right, we have no way of knowing or separating it out. And so, you know, the reason why this is unoptimized is because inside of the player class, well, we want this to work, but we want this to work different ways for different things. Now, if I were to describe it to you, how would that be? That would be, well, we'd want to say that the list at I, when I add one more condition, is a type coin. And that would work. Right? We don't collect the wall. Now, our next task is to make this even more dynamic. Now, we don't know who's using it. Enemies could be using it, players could be using it, other things could be using it, game objects, I don't know. Something with an effect, maybe it's trying to catch the player. Who knows what it is? And they're going to want to interact with objects in a specific way, in a very certain fashion. And you can do this. You can make who knows? Maybe you have lava and a unit enemy. If you push your enemy unit into it, it turns it into a solid cube or something. That sounds kind of cool. I think it's kind of cool. But we need to interact with these objects in a very specific way. So the question is, how can we do it? So first thing, let's make this into a function. Make this into a function inside of the game object class. It's going to be called a public function collides. And it returns the game object you collide with. Sounds about right. Now you want to make this dynamic, so you don't want it to be coin. You want it to be something, but you just don't know what. So here's the thing. How do we make this dynamic? That's our next test. If you can do it, good job. If you can't, well, listen up. We're going to take in a types list. It's going to be an array. We don't know what it is. It's actually going to be a list of classes. And we're going to say for each item in our list, go through another, Control B, go through another for loop. Now, what's this for loop all about? Well, we want to see if the list at I is of type list at j. Now bear with me for a second. The second for loop is based off the type list.length. So we're iterating through our array. And we say, okay, list at I is of type list j. So it's a class. It's essentially our coin. So we say, okay, type list an array. We pass in our coin. Say, is it a coin? If it is, and we collide with it. Now here's another thing we can do. We can actually just turn this into a variable. Instead of saying list at I, we could just say current. Which the game object is actually a little cheaper. Generally, if you use it more than once and you're accessing an array, you should probably make it into a variable. It's dynamic, especially in that module of code. Type list I am not going to make into a variable because it's not going to be used more than once. Current is and current is. Great. So we go through our type list and we find whether or not the item that we're colliding with is both a coin and I'm currently colliding with it, and it's not equal to this because it's probably a very unlikely place. I mean, like players collecting other players or enemies collecting other enemies. I mean, it could happen, but probably still don't want to collect yourself, so just to be fair. Then if we do find it, return current. That's the game object we found. If we don't find it, return null. There was no collision. That's fair. So if we go into the player class, what are we going to do? We're going to say if, I'm going to say coin. Make it another object. We'll store a temporary object. So it's we could say it's a game object. Let's say make it a game object. We don't have to cast it. We can say we don't really care to do much with it. All we want to see is if the player collides. I think I'm going to rename that function. I'm going to call it collide. Do I collide with a coin? Now, if coin does not equal null, and I could probably just leave it as coin, so it's the same as writing this, then coin dot destroy. Very good. Now this works exactly the same way. Now let's say if I wanted to collect other coins or other players. So let's do some fun little things. So walls are the only things we cannot collect, but we can collect everything else. But we can't collect a player because they move at the same speed. So what if every object, every player that's created, we multiply it by his speed by math.random. They all move at variable speeds, right? We can see some move faster than the others, and they all kind of work now. They all collect coins. Doesn't matter which one collects what. It's a kind of fun little way to play with things. But we also want to be able to collect players. So move over coin. We're passing in our list. We're also going to pass in player. So not only can we now collect coins, we can also collect players. We're just going to start running into each other and see who collects what. Alright, we only got 2 players left. Those are the really slow ones. Slowest player wins out. Oh, you. But he can't even collect any of the walls, and we can see that. So you can do fancy and fun things like that. I think I know why things are going a little weird on me. I'm going to disable keyboard shortcuts. Yeah, see, now it won't keep on snapping out. But, yep. That's our first test. Now, to actually get walls to work, this is a little important, because you do want to collide with other objects in the world. To get walls to collide, we want to collide with walls. We've got a movement issue. We've got to be able to move, test whether or not we collide, and move back. Now, this is fairly important. This happens a lot in games. Usually it's locked toward the player class, but you never know. Sometimes it might be a little bit more dynamic, and as such, I generally put it in a game object class. We're going to create a function, move by. It doesn't return a game object. So how do we know if we collide? Well, we also do the same kind of thing. We passed in a type list, the things we want to test, i.e. we want to collide with if we do hit. And the other thing we want to send in is we also want to send in a $x. And now $sign doesn't mean anything. It's just a special character that can be used in Flash. I use it because some JavaScript programmers use it to connote a local scope object that variable doesn't exist at the end of a function. And that's a pretty good practice to get into. So I can look at a code and see what it's doing. I generally use it anyway. So what do we really want? Well, we really don't care for anything. I do have to supply an x and a y. And I don't really care what order it's in, so why don't we just say, well, this could be equal to 0. This could be equal to 0. And this can be equal to null. You know, no value. So you don't collide with anything. This is also fairly important because we're going through a for loop, and what if the type list is null? We haven't handled that. So we should just say, if we have a type list, probably are going to have one, then evaluate. So even if I don't supply, in this case, even if I don't supply a type list, it won't do anything weird. And you're asking why? Why is it related to the collide function? Well, that's because it's fairly simple. I created the collides function so we can use it. So now let's move you use it. So we're going to say x is going to be plus equal to $x. Done. Now if we collide with our type list, I like shortcuts. I don't like typing either. If we collide with our type list, then what are we going to do? We're going to say, oh, okay, we collide with our type list. Move back. Now that was fairly simple, but you know, if I had to type this out individually, there'd be a lot of for loop. So you know what? Collide isn't so bad. That's one. What do I do for the y? Well, it's fairly simple. Duplicate it. Just set it to y and set it to y. This way we can totally tell if we're colliding with something. And we can do one other fancy thing. So if we say var $collision, let's say we wanted to know what we are colliding with, what kind of game object we are colliding with. We can say collision, put this in brackets so it doesn't throw a weird evaluation error. These are warnings that generally pop up anyway. The one warning I am getting as a result is on mouse move event, which we're not even really using. We're getting that because it's the same keyword used in AS2. We're not using it, and we're going to take out all this code because we don't need that anymore. Though I do like the Hello Kitty. Let's take all the rest of this stuff. We don't use any of this stuff. Great. This is our game engine, and I like it. I'll show you some cool things in a little bit. So you say, okay, y plus equals y, okay, great. Now, what if I actually want to know what I collided with, so I can do something to it? So if I collide with an enemy or collide with another type of object, I send it off in the other direction. So I can say, I can create an onCollideX function that takes in my collision, and the same thing for onCollideY. And we actually don't really have to do anything here. We're just creating stub functions that other classes can theoretically handle. So Control-Shift-1 will generate public function. Control-Shift-1 will generate a public function. And we'll leave those, because let's say if I wanted to use it in my player class, they'd be there. What else we need? We don't really need much more. I mean, this is pretty awesome as we've got going. Let's just see it work. So I can collide with other players in coin. That's kind of cool. What are we going to do? So instead of saying x plus equals velocity, y plus equals velocity, I'm going to say move by. And I want to move by x by y. And type list. Now this is super object oriented. And if you've got any sort of inkling as to how this kind of functions, you'll start to realize, wow, this is really, really cool. I've just typed about, like, 10 lines of code. It's a little bit more than 10 lines. But if we would have distilled it down, if we took out all these brackets, we probably would have 10 lines of code. Probably end up with 10 lines of code. And you'd be like, wow, I got a working player. It was super simple. Like, well, what? It's just one collides function and one move by function. And the functionality is reusable. And that's the most important part. It all works. It's all functional. It's all dynamic. I can go into the player class and I can say, well, I want to collide with walls and stuff, and I don't want things to blow up, but it did. So let's do it blow up first. I have no idea. Oh, it does. So that's not the problem. Player must have class. Okay. Game object expecting right param before left brace. This is the one. That's got right number. 1, 2, 3, 4. Somewhere my brackets break. So, if you've been following too closely, you might. Oh, right. I don't have an extra one of these. There we go. So, yeah, sometimes carry that. Read your errors. They can tell you a lot. Expecting right param before left brace. That was the error. All the other ones just kind of said 1 because they weren't really broken. It's just because that one failed to compile. The rest of them are just, thrown out there as well. It thinks that they didn't work out right, and it's true. They didn't compile. So I double-clicked on the error. My error said this line. I just added a bracket. You can count the brackets, and inside of Flash Develop, it kind of highlights the ones you've got, so you can see to make sure that they're all interconnected right. And yeah, that's working now. One more. There we go. So now we can move our players. This is kind of rad and great. And they also collide with the walls. Now they can kind of go through them a little bit. I know that. You can do things to, and this has to do with our more normalized function. If we take out the normalized function, if we comment out the normalized function just momentarily, you can see that this doesn't happen. Right, they don't go through the wall. Oh, yeah, they still go through the wall. Oops. Right, it's also because of my math.random. Let's take out the math.random. I'll explain to you in a sec. Right, they don't go through the wall. They don't slide through the wall. And the question was, why were they doing that before? Well, like, it's a pretty simple explanation, really. what was happening is, well, it's actually a really complex explanation. What was happening was that it hit its mathematical limitation, right? Every number has bits and bytes. Now, because these are numbers, they have far more bits, or a couple more bits to work with. But when it runs to the end of the bits, it's working on the smallest number, the smallest fraction, and you're adding and subtracting. You can sometimes the mathematical equations are don't necessarily work. It's due to its level of precision, and to sort of create a failsafe for that, you could do one of two things. Inside your game object function, you can actually just round down the number. You could say, well, I want it to be to this level of precision is equal to x divided by, say, 1,000. We'll call this we'll get a variable called precision. Even make a constant of it because we're never really going to use it again. It's going to be, we're never really going to change it, so we're going to say precision is going to be equal to, let's say 1,000 precision. And this is probably super unimportant because when you think about it, like 1,000th place, it doesn't really matter that much, so sure, why not? So we're going to math.floor rounds down. Don't know what it does. Hit F4 on it. And again, we'll do the same thing, and we also want to multiply it up by 1,000. So theoretically it hasn't changed anything, but because when we round down, and I got my signs backwards actually, should be times, so let's say if it was 999, I don't know, let's say 1, 2, 3, 4, 5, right? So 2, 3, 4, 1.2345. 2, 3, 4, it'll be 1, 2, 3, 4. And then the 5 gets rounded up, so it'll be 1, 2, 3, 5. And then we divide them all, or, well, actually it gets rounded down, so it's 1, 2, 3, 4. It's always rounded down. And then, so when we divide it back again, it's 1.234. The 5 gets cut off. And that's essentially what it's doing to both the x and the y, so it doesn't have any really strange fractions because they break the way that hit tests are calculated. And we don't really want to do our own custom hit test. It's probably cheaper just to rely on flashes, especially since this is a fairly good one. So yeah, we'll just help it along a little bit, and we'll run it. We put everything back the way it was. We'll run it, and hopefully, we won't go through objects. No, 1,000th is still too much. So lucky I left mine as variable. I think it's 100th that it doesn't really care about. You kind of find the sweet spot. And 100th it still cares about. Wow, talk about a tough customer. At some point it stops caring, I'm sure. And I was right. It's at 10th. Yeah, that's not really the end of the world. I mean, it may be depending on how fast you're moving, but you can usually tweak those values, so it works out about right. I think there was one other thing we could have done. But the reason why this is also super important is because, no, you know what? Yeah, that's fine. There is another way. There might have been one more way around it, but it's this way is probably the best. It looks the best too. So, and it's also part of the cheapest. Well, that's about everything I think for today. We don't have multiple levels, but that's all right. We can kind of create our levels, you know, top-down stuff, and we can also give them all the same kind of speed. But let's just kind of mock out a level just to see what we kind of got. Now, if you want, what you could theoretically do is you could say, you can go to grid, edit grid, also show grid, and we want it 32 by 32 because everything's going to be 32 by 32 in our world. Snap accuracy, normal is fine. Show over objects, that's all right too. Snap to grid, yes, turn it on. And that's good. Now we can just kind of like mock out our level, and for some reason they always seem to snap off like by the center instead of by the corner, which is kind of a bummer. I think there is a way to fix it, but you know what, I haven't really figured it out, so not the end of the world. If you hold Alt when you select and drag, you can get a whole bunch of them together, so you're actually just creating a clone of all those objects. And I'm going to generate a, let's see, players over here. That's all right. And I actually don't want them to be 32. I want it to be a little bit smaller so he can actually fit through those slight spaces. Make them 30 by 30. And yeah, let's delete all these now. Yeah, they're all off center now. So let's pull out a new player. So his registration points in the center. Great. So 30 by 30, that means 1 pixel on either side, on every side. I'll just drag a couple of these out, and we'll have him running through a maze. Ooh. Oof. This is a tough maze. Not to be anything too fancy. I'm not actually making anything fancy. I'm just trying to make it a little interesting instead of it being all redundant. But yeah, sure. We'll pull these out. No, let's leave one of these open. And we'll be like, we can go this way, but if you go this way, you only get a dead end. And the real path is out here. But what you can get inside is coins. So gotta love those coins. You get 1 coin for just exiting, but whatever. So we control enter, and this is our level. I may be starting colliding. I was hoping not, but apparently I am. Am I? I don't know. I actually really don't know. So let's move these objects out a little bit, just so we don't start inside of an object. Let me see. Am I starting colliding with an? Oh no, I'm not. But I am a little too big. It's because I move at. No, it's not because I move at 5, but doesn't hurt. So let's see if I can make them a little smaller and see if we can get that all working out right. So you're 30 by 30. Let's make you 28 by 28. And this will bring us into a topic that we'll discuss a little bit later, which is collision fields. This can get a little bit iffy when you're talking about, well, you know, my player is huge, but I want my collision blocks to be small. How do I do that? Oh, you can see that was actually a tight squeeze because you have to like perfectly line up. You don't always do that, so like I'm not oh no, I broke it. But there are ways to kind of fix that level of precision. So what's happening is it's not actually colliding smoothly up against the wall. It's actually letting me I'm staggered a little bit. So it's moving me back the way to the distance I was, to the distance I was at, as opposed to pushing me flush up against the wall. And you can do that. You can flush up against a wall, and I'll show you how that can kind of be done. I generally don't like doing it because it's a little bit more expensive. But the easiest way to do this is alright, I'll show it. I really don't want to show it, but it's a while loop while you're colliding. So you can say while while there's a collision. It also means we have to create a new var declaration last collision. You'll see why in just a sec. It's also a game object. And what we want to do is we want to move back. We don't want to move back by that amount. We actually want to, one more variable, direction. So last collision is going to be equal to $, collision. And var direction that we were heading in. That's a number. And we can reuse this to, actually this is an integer. We can use this for any sort of thing. We can just say, well, what direction are we in? Direction is equal to, this is going to, I'm going to show you a ternary. This is a one-line if statement. Works out really, really well if you just want to do an if-else in a single line. So if x, $x is greater than 0, we're heading in the positive direction. That's our question. So condition, this is true. If it's true, is on the other side of the question mark. True, I want to say direction is positive. False, this is on the other side, is negative. That's how it works. So this is condition, and if it's true, if it's false. Doesn't have to only be numbers, it could be any other kind of thing. Yeah, one line if statement. I'm going to do the same thing for the y. We don't have to really store these separately because we're just reusing them. I mean, we don't really need to do anything fancy with them, except for when we're moving back, we actually want to move back by the direction. Direction divided by precision. So until we're no longer colliding. You can do it other ways as well. You can get the bounds of an object and just snap to it. But this way is probably, I don't know, more precise. Let's just say that. So a tenth, it'll move a tenth every time. Until it stops colliding, and that'll flush up against. So then we set our last collision, because if we had a last collision, if last collision, then say that we call the onCollideX function. We want to set the, it also means that we want to set our last collision to be equal to null here, so we don't double up on collisions even though we don't collide on the y. Same kind of thing here. Direction divided by precision, and onCollide y. Yeah, we'll just pull this out. And a little bit more wordy, but this works in a very specific subset of cases. Usually you can get away without them, fixing them, but since I showed the bug and explained the bug, I didn't want to do it. Felt like I was cheating you guys out of a solution. I do know the answer. Just sometimes it takes a little bit of code to get it working. As you can see, our moveBy function is a lot bigger than it was, which is not necessarily the greatest thing in the world. It makes it a little bit more complex, but you know what? It's modular, so you can use it anywhere you want, and it'll work. That's the most important part. Obviously, it's not working quite as intended. I may be using the wrong direction. What is that thing doing? Something seems to be off. Something seems to be way off. Let me take a quick look. Oh, it's late. I should go home. But I do want to get this thing working. First, so let's actually just debug this problem. Debugging is fairly simple. Take away everything that could theoretically hamper our debug, and just test things in a very solitary singular case. One block. I collide with the block. Pushes me back. It's good. It's exactly as it's supposed to do, except on the y's. And it's only the y's. The x's work fine. So the question is, why does our y not work quite as we want it to? That is actually a good question. And the answer to that is, I have no idea. If you can figure this out, let me know. I will try to continually figure this out as we are, who knows, I don't know. I don't know why the y's are blowing up. Why doesn't the y like the x's and the y? Oh, right. What's wrong with the y? If you found this, good on you. It's not a while loop. Ha 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 ha. So this one only happens once, and of course it's a little bit more than once. I mean, it has to move quite a bit, right, because our precision's pretty high. Now if we can collide on any object, I knew I was thinking about that halfway through, and then... Yep, you want to code in a very logical way. There we go, now everything's back. Now we can do our collision, we can hug up against the wall, and it doesn't really matter. Right, when we come back down, we can hug up against the wall, and it doesn't really matter. Just want to get through, and we're through. Hug against the wall, it doesn't matter. And you can see that even though we're hugging up against the wall, we're right at the bottom. There is no space. Right, anyway, good on you for coming all this far. This is like 2 hours. Usually I try breaking up into smaller chunks, and next time, this is probably the hardest chunk we'll deal with. There's lots of information, lots of modularity, but this is essentially a game engine right here. You've got a functionality that is dynamic, easy to use, easy to script in what you want it to do, and you're pretty much good to go. Hopefully we'll keep on extending this. We've got lots of things we need to add, like camera manipulation, and maybe we will make this into a some sort of side-scroller. Some sort of jumping side-scroller. We'll add gravity in there. We'll add a whole bunch of fun things to play with. And maybe some enemies. Enemies are always fun. Maybe some lasers, bullets, who knows. We won't go super crazy with this, but there's still a lot of little elements of functionality that probably are fairly important for a game engine. So hopefully we'll step through all that kind of stuff, and good luck for sitting through this, and I'll see you next time.